Welcome in this video describing the Arcadia method and the Capella workbench with an example. The example is a level crossing traffic control that is used by Jean-Luc Voirin in his Arcadia book. Jean-Luc Voirin is the main author of the Arcadia method. In this video, Jean-Luc will focus on the customer operational need analysis, what the users of the system need to accomplish. He will show how to define operational capabilities, identify operational entities and their activities, describe operational processes and scenarios. He will try to forget the boundaries of the system and focus on what the users really need to accomplish.
Let's focus first on operational analysis, starting with the expected missions and capabilities coming from the system. Here we can see that the system is expected to deal with two different missions, one which is preventing any collision, of course, between trains and road vehicles, and another one ensuring fluidity in both traffics, both for road vehicles and for railway vehicles. Each of these two missions needs a set of capabilities so as to be able to be fulfilled. So, for example, having the ability to detect and acknowledge trains approaching the station, acknowledging as well approaching road vehicles, and of course forbidding the simultaneous access of both to the crossing itself. We have added one extra capability here, which is just because we are in a situation where our level crossing is situated near a railway station and in a city, so we have to deal with that, and especially to ensure not blocking the traffic on the road, but possibly, in some cases, temporarily prioritize this road traffic as well. Of course, we can consider entities that have to deal with this mission. Here they are. We've got, of course, the traffic, which is built from trains on one side and road vehicles on the other one. We have differentiated trains arriving or approaching the station and trains which are leaving the station because they are managed differently. And we could also have separated cars from heavy trucks or from two-wheeled vehicles, for example, if they had to be managed differently. Here they will not. They will all be managed the same way, so we could consider only the road vehicles as a main operational entity, and this is what we will do. Of course, we can add the railway station that will contribute to those different regulation actions, and of course the operator themselves, both the traffic regulation authority and the road maintenance team as well. We could have put others, but we focus mainly on the traffic regulation itself now. So based on these entities and missions, let's try to see what are the kind of activities that each of these entities should perform so as to fulfill the mission. This is an example of the different operational entities that we have seen up to now, with each of them contributing to the global mission by activities which are depicted in orange here. As you can see, we've got the station itself that will decide to launch a departure procedure for trains leaving. We have trains that start and cross the crossing, trains arriving that will approach and then cross the crossing, and of course road vehicles that will have to stop and once they have a clearance are allowed to cross the crossing. And the traffic regulation authority is in charge of just stopping road traffic for the moment and allowing it to proceed when the train has crossed it. This is a standard way of dealing with country-situated level crossing systems. So here we just decide to act only on road vehicles just by having the information that the train is about to cross the crossing. So this is a simple way of dealing with them. But we are in another situation where we have to face different conditions, and this is important at operationalize this level. And this is what we will show now. We have, for example, to face feared situations that are, from a safety point of view, dangerous and that the system has to prevent from. Let's have a look to these feared situations. Here is a high-level view of those situations. We have chosen to represent them in a scenario, so a diagram which is time-related with a time which is a vertical axis, and we have different contributors, the different entities that we have seen here. We have the trains leaving or arriving in the station, the road vehicles, and the regulation authority that has to deal with that. For example, we want those different situations to be avoided, such as the one where a road vehicle would cross the crossing simultaneously as a train is leaving or a train is arriving in the station. We want to avoid situations where the road vehicle not only crosses but is stopped on the crossing, while a train leaving or arriving would cross it as well. And we also want to avoid the situation where we would be either crossing the crossing or stopped on it, while traffic would be stopped as well. So we want that once we have decided the traffic to be stopped, all road vehicles be prevented from entering it. So this leads us to a new version of the high-level operational ISIS. We have to revisit it according to those new expectations and feared situations, and this will lead us to modify the previous operational view that we have defined up to now. Let's have a look to it. Here we can see the same kind of operational ISIS that we have seen with the same actors, but as you can see, the work is much more dense in terms of activities. Here, because first we have decided that the regulation authority should not only act on road vehicles, but possibly also on trains leaving or arriving the station. This because we have seen that we have some situations, for example, where a road vehicle is stopped on the crossing, where we have, for safety reasons, to stop the trains as well. So this is what is to be done. So we have added ability for the authority to stop the trains, both arriving and departure. In that case, it has, of course, to analyze the collision risks, and based on this analysis, to define some clearance for either road vehicles or trains to cross the crossing or to stop. So as you can see, we have much enriched the operational ISIS so as to deal with safety constraints. Here again, at operational level, we have no idea for the moment of what part of this will or not be taken into account by the system itself. If we focus more on dynamic issue, we can, on this operational ISIS, have a look to some kinds of steps of activities that are involved in this operation. So let's have a look to processes here. Here they are. As you can see, we have the same analysis with different activities, and we have defined here a set of operational activities that are all linked by, of course, interactions that will define what is to be done in different situations. For example, for a priority train departure, we will start from the launch departure procedure activity, and the regulation authority should analyze the risk and then deliver authorization and possibly blocking road vehicles and so on. Okay. If we consider free vehicle passage, well, this works differently, starting from a vehicle arriving with the clearance coming from regulation authority and sending back the authorization to cross the crossing as well. Now, if we want to get a more precise time-related description, we can use scenarios as well. So with nominal train departure, for example, this is an example where we see the different activities that each of them has to perform during time. For example, the regulation authority is one that the train is ready to leave. We have some road vehicles approaching. then we have to define whether there are some risks of collision according to this information to stop road traffic, and then go on through, once the vehicle has been stopped, to give authorization to the train to depart, what is done by the train itself. And once this is done, now the regulation authority can allow road traffic to resume, and this is here how it's done. So as you can see, this is a time-related description that will emphasize the whole description of this departure scenario. Similarly, we can consider a train which will be delayed because of a vehicle already being crossing the level crossing itself. So as you can see, it's a bit different here. We can have a definition which is similar to the previous one, but of course, as soon as the train prepares to leave, the regulation authority, given the fact that there are some vehicles crossing the crossing, will first delay the train, and once the vehicles have crossed the crossing, will go on in the nominal train departure scenario, which is the scenario that we have seen just previously, meaning this one. So as you can see here, we've got one preliminary part of the scenario, which then goes to the nominal one. If we consider now the different situations that the level crossing has to face, we can have a look to the different modes that have to be managed by especially the regulation authority. Here we can see the different situations, the different modes where the regulation authority can be. It can have to manage train departure, train arrival, and of course the standard road traffic without any departure or arrival of train. So if we consider each of these different modes, we can define what kinds of activities are expected in each of them. So for example, if I look at this mode, road traffic, I can see with a semantic browser here that I have different activities, which are those ones that have to be assessed during this road traffic situation. And of course, we have some transitions from one situation, from one mode to another, which is described that way. For example, if a train arrives, then we get a train arrival information that will lead moving to a train arrival mode. And of course, as soon as the train has arrived, we can either go back to road traffic or possibly move to train departure and so on, depending on the different events that appear during the life of the level crossing. Last point for this operational analysis, we have seen a set of capabilities, a set of activities, operational processes, scenarios, and so, but no clear link between capabilities and the rest of the world. So let's have a look to this one. For example, if we consider the capability that was to forbid the simultaneous access of vehicles and trains to the crossing, now let's see what it is made of. For example, here, the semantic browser shows us that this capability is defined by two operational processes, free vehicle passage and priority train departure, and that it has three different scenarios that we can see here. Nominal train arrival, nominal train departure, and feared situations.